morning. Good morning. My name is Marinatika Michelle. I'm a group leader, number 2. So I'm very excited to share with you what we have found out along with my colleagues. So we are group 2, as you can see on the PowerPoint, and we are here to share with you the teaching and learning strategy for concepts and principles related to electrodynamics. So before we dive in, I would like to share with you this quote, which says that, "Tell me and I forget, teach me and more I remember, involve me, I can learn." So this proverb, it is about Chinese proverb. We will dive in exploring how we can teach using interactive teaching method. There is another saying said by Albert Einstein, which says that what we cannot visualize cannot fully understood. You see, in our teaching, we need to show learner what is really happening. So, like as we will see in our presentation, we will try to share with you the proven teaching strategy. We found out that it can help students to learn meaningfully. So, as an introduction, we found out that we have to use learner-centered methods instead of using traditional teaching methods, because we want to develop competence among learners rather than rote memorization. As you know, electrodynamics is highly mathematical and abstractical. You know, physics goes hand in hand with mathematics. And sometimes students struggle to understand those mathematical concepts. That is why in our presentation we proposed this proven teaching strategy. The first one is we will look at deeply is project-based learning. The second one is integration of technology. We will dive in exploring simulation, animation, and virtual lab. We will also look at 5 is instructional model. Very deeply, you will understand it and know how we can use to make these difficult concepts of electrodynamics to make it easier for students to understand. We will also look at hands-on experiments and also discrepant events. So, thank you. I hope you will learn more about our presentation. So, my registration number is 22 30 12 163. I would like to invite the next presenter, Marina Simoge, to continue with the presentation.
Hello everyone. Yeah, I can see that you become somehow tired. Now help me to do this warm up, so I want this room to be energetic. Yeah, I'm going to say I'm a toaster, and you're going to respond I'm a toaster. I'm a toaster, toaster, toaster. Toaster. I'm a toaster, toaster, toaster. Toaster. I'm a toaster, toaster, toaster. Toaster. I'm a king, I'm a king, I'm an I, I'm a C, I'm an I, I'm a miss, I'm a toaster, toaster, toaster. Toaster. Toaster, toaster, toaster. Toaster. Thank you. Now the next point is project-based learning. Yeah, as you said, is concept of electrodynamics need to be more practical than theoretical. So about this, we need to do more practice. In this project-based learning strategy, the teacher tries to give the tangible tasks. Like next year, the previous year, we've tried to do some projects like using DC motors. We've made the conditioners, air conditioners. This is very tangible and it have helped us understood more about the concept we were studying. So in this concept also, it's better that the learners can be given tasks and dive in them to deeply understand them and make like real life solution of the problem which are in our world. Like we are making people who make new things. Yes, and it will come up from the project-based learning, where the learners who will be taught how to deeply do their own projects through application of electrodynamics can do, like project which can also compete on the market. Thank you.
Another strategies which you can use by the time you are teaching electrodynamics, it is the integration of ICT. By the time you are integrating with the technologies, there are more things which contain the information that helps learners to get the information from that abstract concept. For example, if you look, you can see simulation. By the time a simulation is being created, you try to use mathematical formulas. By the time allowing us to change the parameters and observe how things is looking like. You get the point? For example, if you are working on Faraday's principles, the simulation can allow us to how, by the time we change the size of the coil, how magnetic field will inducing the electricity. Or by the time we change the magnetic field, how the electricity is being also induced. Let me invite another follower.
Thank you very much. By the name of Yvonne Daisinga, I'm a member. I'm going to show you another strategy, which is animation. This animation is a powerful tool which is visual that can be used in this electrodynamic model to show the interaction between electric fields and magnetic fields. As you see that this is used to engage and even to explore and to explain to learners how the magnetic and electric field they behave, whereby the magnetic field and the electric field they are perpendicular, and this shows that this also they can form, which we can call the electromagnetic wave, which is a transverse wave. Note that in transverse wave, the direction of propagation, the direction of the wave, they are perpendicular, as you see in this diagram. Also, by this animation, we can explain for runners different concepts in electrodynamics, including charges in motion, and even including about the Maxwell equation and how they work. Also, we can use this to show that according to that animation shown in this slide, we have the perpendicular line, whereby there is formation of 90 degrees between the magnetic and electric field, as you see in here on the board. Also, this animation can be used to explain different concepts in electromagnetism, the model we've seen in previous year. Thank you very much. I'm going to invite my fellow colleague Fabiola to explain about virtual labs.
So thank you. Before Fabiola continue, we would like to share with you the simulation that shows us how we can teach Faraday's law in class. This simulation is going to be facilitated by Gaspar. He can come up in front and show us the Faraday's law, how can be taught in class.
Okay, thank you again. I'm going to show you how this simulation is working on. From here, we have different parameters. It is based on Faraday's law. In Faraday's law, we have one magnetic field, which is created by magnet. Second, we have a coil. We have electric field, which is generating electric field, which is showing how electricity is being performed. And we have another one, which is called it is not electricity, it is ammeter. To measure the amount of current which is being produced. Yeah, we can change these parameters. What if happen if we change the size of coil? It is shown by the simulations. What if we change the magnetic field? You will observe what happened. Or what you think happened is shown by the ammeters, or times you can use bar. By looking how the intensity of rate produced is being changed according to the changes of these parameters. Let us dive in within by showing my activities.
While he is showing us on the simulation, I would like to write the formula of Faraday's law. Where induced current is equal to change in magnetic field around the loop induced current. So it is going to help us to explore this simulation. You can put magnetic field. Yeah.
Yes, we are going to look how, by the time we change the size of coil, how this electricity is going to change. Here we have a coil 1 and we have a magnet. By the time we are taking the magnet and we try to induce changes, we are looking how the light is being changed. So,
do you see what is happening?
You can also
Yes, he is inserting the magnet inside the coil, then it induces electricity. It is about what is written in this formula, where changing magnetic field in the coil, it induces electric field. He is inserting the magnet into the coil, which is changing with time, then electricity is induced. And you can see the bulb is light.
we can also change this there. Okay, let us use this small one. If you use this small one, we are going to look how it is being changed.
It is not visible.
It is not visible. It is due to the influence of the boss. Okay, let us follow another point.
So I would like to invite the next presenter, who is Fabiola, who is going to tell us the hands-on experiments and teaching using practicals in class. Fabiola, welcome.
Good morning, class. I'm here to present about the hands-on activities and the activities to practice the theory or the theories or theoretical
in the courses or for example, in physics into practice. Then this method of teaching physics connect the abstract theory to the real life and can solve the real life problems because students or runners understand very well how to use the theories into practice in their daily lives. For example, in labs, students may work on an experiment of how to verify Ohm's law. Where Ohm's law is said that the produced velocity is directly proportional to the current, the constant of resistance. Voltage is directly proportional to the current produced by the bulbs from the cells as they are connected in the activities. Thank you.
So thank you very much. Thank you, Fabiola. And also to welcome this month to tell us 5E's instructional module. So let's dive into it.
Thank you so much. As usual, my name is Matthew Amo. Second, I'm a member of group. As usual, we have 5 structural model as another strategy, and it is also familiar with this. The first one is engage. In engage, teacher surprise student through demonstration. Through the demonstration, when a teacher are teaching electrodynamics, for example, they need to use a given demonstration. The second one is explore, where we can use hand or a simulational activity as indicated. And the third one is also explain. In this instructional model, teacher needs to formalize the concept firstly and explain immediately their concept. The fourth one is elaborate. In elaboration, teacher needed to apply the new related situation for their concept. And first, we need to access in evaluate phase. Let me allow Mr. Jonas to give an example through teaching columns law and using easy instructional model technique.
Morning. How are you? I like that. Some point I don't know. But we are going to continue with the example of how to apply 5E's instructional model as this massing. But we need to talk about it. 5E's instructional model. This is instructional model. We're going to start with this engage. But this is an example. Teacher can engage learners while teaching these concepts of electrodynamics. Like, for example, I'm going to talk when a teacher want to teach the concept related to Coulomb's law, he or she might firstly take like a paper, may take your own like a pen, and he may or she may lab it on a crops or in here, you know, in the primary we used to do this. And let the learner observe what is happening. You get me? Yes. Labbing a pen in the hair, and attach it to the paper and ask the learner what is going on. That is about engage. And the second one is explore. Teacher may give learners balloons, no balloons. You don't know. Why are you like that? But to do what? In this explore, where the teacher gives the learner balloons, they may ask them, the learners, to rub each other. And while rubbing each other, they ask them to talk on what is happening in this explore phase. You get me?
Yes.
And the third one is about the explain phase. In this explain phase, why the learners has been left the balloon and they observe the repulsion, you know, although the teacher profit by then starting to introduce the concept related to Coulomb's law. By the purpose of showing the learner the difference or the relation between the electrical force and the distance. By showing them that the electrical force is equal to, what does this tell me? Is it? Coulomb's constant. Yes. Okay, and charge, if the charge is different, over R square. This is the direction. And the phase number 4 is about the elaborate phase. In this elaborate phase, the teacher may profit by giving learners the homework, or asking the application of this Coulomb's law in real life, like examining how the charges, positive and negative charges, are interacting in these electric wires. You get me? And this in evaluative phase, this is the phase where the teacher may give the learners like short quizzes or asking them to work on the electrical field lines. Thank you.
Yes, good morning. By the name of Ejide, let's continue on discrete party event. When we are saying a discrete party event, we are meaning any event or any activity that takes place in the class, just to make a conflict with the students' mental thinking, or mental thoughts. So it's like we are making the students think like to say, wait, this is what you were expecting. Yes, it means the students are getting to know, to see what is happening, but unexpected result to them. Let's try to link like with electrodynamics. Okay, so we are having an example here of a discrete event called wait a bit. Yes, a jumping ring discrete event. We are having the materials used here. Okay, so this man called the Thompson, he takes a solenoid metering. When I say you are going to pass through these materials are not there, okay? Then he took a solid metal ring, then he put it over in iron core, then he turned in AC power. Okay? Then the students were expecting that this ring will ring only. Okay? But as the result, the ring suddenly jumps into the air. Okay? Then again he replaced this a solid metal ring, then just instead of using this metal ring, he used a metal ring but with a gap. Okay?
Yes.
Then once he uses a metal with a gap, there is nothing happening. At this, we saw that the ring jumps into the air. Okay? But here, there is nothing happening. So the students asked why. Some of them, they were thinking that the ring will ring only but not jump. Okay? Then as a result, it jumps. So, as you understand this conflict, that make the disagreement, the conflict among the student force and the result. Okay? So this was targeting to help them to see how changing magnetic field from the solid to the solenoid will be resulting to give the induced current. Okay? And this can be used to teach the students about Lenz's law, magnetic repulsion, and so other scientific topics related to electrodynamics. So, thank you so much.
As we conclude, we have said that as conclusion, let us use active teaching methods and let us use methods that help us learn to see what we are teaching. So we would like to welcome your comments, any negative comments, positive comments, and highly appreciate it.
Thank you very much for your presentation. I really appreciate you for your presentation. And specifically, I'm going to talk about the points of appreciation and the points of improvement. So you will try to use the simulations, and you will try to show us the specific examples. Also, you will try to explain 5 E's instructional model using specific examples where Mr. Jonas had tried to explain it by using a Coulomb's law. So that is the point of appreciation. But the point of improvement, I think all of you have seen that the time is still a challenge. So the time consuming is the point of improvement. You have to summarize to make your expression clear in short time. Yes? So that is what I can comment on your presentation. But in a few, your presentation is interesting. Thank you.
Anyone else? Anyone else to comment?
Okay, I can say something about your presentation. You really tried to present something good. You give them your time, and the PPT well okay, and also you really try to dive into field simulation, and like it was more practical. So what I can say about the improvement, you really need to get to know how to summarize well your things. Like now have taken the time for about 3 groups presenting, like you use more time than it would be. So the time was challenged, but other things you really tried. Yeah, congratulations.
Thank you very much. So I really appreciate you for your kind attention. Have a nice day.